hope everyone's having a great day, and I appreciate the hour of your day that you're going to be giving me today. As Whitney said, my name's Don Spurkey, and I've been with GT Software for more than 15 years, talking about accessing and integrating to the systems of record applications that run on the IBM mainframe. For the longest time, the folks that were responsible for mainframe computing really weren't affected too much by the hybrid IT trend. We ran our systems on premise because the reliability, scalability, and security that's inherent with the mainframe. But in the prolific words of Bob Dylan, and I'll spare you my singing, the times they are a-changin'. Now, I'm not here to recommend, even though I'd certainly love to do that, but discuss the challenge of what to do with your legacy systems of record as it relates to hybrid IT, most specifically the cloud. Before we talk about today's topic, please allow me a few minutes to introduce you to GT Software. GT Software is a privately held software company that was founded in 1982, and we're headquartered down here in Atlanta, Georgia. We've been a mainframe company since our inception, and we focus on real-time mainframe integration for strategic business initiatives. We've got very broad experience across all mainframe and distributed environments. As you can see by some of the logos on the screen, we've got some very, very impressive list of worldwide customers. If you'd like more information about GT Software, you can find us at www.gtsoftware.com. So let's begin the discussion of where we are today. We have the mainframe, and then we pretty much have everything else. And I say that flippantly, but the mainframe really is the 800-pound gorilla. It's a platform unlike any others, be it because of its database types like VSAM, IMS, IDMS, and others, its programming languages like COBOL, RPG, and Assembler, its EBCDIC versus ASCII, and we could just spend hours and hours talking about the differences between the mainframe and other systems. And then on the other side, we've got the distributed systems, which ultimately make their way to the cloud. Certainly more flexible in its languages. We have many, many choices of different relational databases. You've got Java, you've got ASCII, and again, the list continues. I think you probably get the idea. So what we end up with is two very different systems, the mainframe and the cloud. And do we strive to bring them together or have them work together? And that's what we're going to talk a little bit more about today. This should come to no surprise to anyone, but there's still a huge mainframe footprint in the world. Even though we've heard for more than 30 years that the mainframe is going away, the mainframe continues to be the workhorse of the transactional world. The number of transactions processed by mainframes every day is approximately 30 billion, and that's a staggering number, especially given the number of physical machines, which, as I understand it, is less than 10,000 in the entire world. As another data point just to ponder, the new IBM Z14 can run 12 billion encrypted transactions per day. ATMs process as many as 23 billion transactions per year, amounting to over $5 billion per day of activity. And 87% of all credit card transactions are processed through the mainframe. Just think of the speed and number of hops between the time when you swipe your credit card and the approval, which happens in just a mere number of seconds. And the amount of corporate data that resides on the mainframe is also a staggering figure. Some may debate the 80% number, and I've seen people say it's as low as 60 and some as high as 85. But this debate, I think, has some flaws to it because they're starting to count the unstructured data in that number. And some argue that that does skew the percentages. My contention is that it's still a lot of critical structured business data, and if the number is a little bit less, it really doesn't matter because it's very, very significant. So as we can see, a great deal of data and workload still resides on the mainframe. But who's doing all this work? I hope we all know that the mainframes are really everywhere. I always get a chuckle when I go to a mainframe trade show and get asked, usually by someone without any gray hairs, are the mainframes still around? I thought those shut down 20 years ago. Well, my response is always, did you choose an airplane to get here? Or did you buy anything on your credit card today? And of course, the answer is always yes. And I make my point and return a look of disbelief. The bullets here really tell the story. 71 of the Fortune 100 and 92 of the world's largest banks rely on the IBM mainframe. The security and reliability of the systems is enough justification to stay true to the platform. And my customers, who all have mainframes, span across every vertical: insurance, healthcare, government, retail, and manufacturing. But I get the feeling pretty much everybody probably knows that already. Before we talk about the cloud, though, let's finish our discussion about the mainframe by talking briefly about the pros and cons of the applications that run on this legacy system. Now, there's very good reasons that legacy mainframe applications continue to be the cornerstone of the Fortune organizations we spoke about on the last slide. Efforts to sunset the mainframe applications and even the platform itself have been slowed or hampered because of the high comfort factor around the reliability of the mainframe, and there's very little risk sticking with what works. No one can argue with the security of the platform, and it stands alone as the system of record. Rewriting or COTS-based applications may not be practical alternatives because the high level of specialization and customizations that have been made to these systems. On the flip side, there's some cons. First and foremost is many of us, or at least me speaking for myself, we're all getting older, and some of these systems are more than 40 years old. This isn't necessarily bad news. IBM is encouraging coursework at major universities, and I know of at least 2 major consulting companies that are teaching COBOL and CICS to their employees. So there'll continue to be a trickle of younger talent. I just hope it's not outpaced by retirements. The next issue of outdated technologies isn't something I totally accept because the mainframe is more than just COBOL. Now we have Linux on the mainframe. We have Java on the mainframe. Both are supported and encouraged by IBM. Now, one thing is true, the talent pool is shrinking, and since the amount of new development is shrinking, so are the available resources. You also see consolidations as more shops outsource to save money and floor space. So shops don't need a stable of DBAs and systems programmers like they used to. So as long as you have a subject matter expert for the application, most shops are figuring out how to get by and get things done. So let's do a 180 and talk a little bit about the cloud. Now, many mainframers may contend that the mainframe was the original cloud. Well, if nothing else, it was certainly the first virtual machine before virtual machines were cool. But today, the whole world is talking about the cloud. If it's not fill in the blank as a service, it's not anything. And trends back that up. And so does Oracle, Amazon, Microsoft, and others. In 2018, 85% of enterprises surveyed had a multi-cloud strategy, which is an increase from the prior year. So that means the actions actually do match the talk. But one thing I do find interesting, though, is the adoption of the private cloud. Not that it's not a strategic direction for organizations, but that it actually fell slightly, which affected the hybrid cloud adoption number. My conjecture is that the confidence in the public cloud is skewing that number downward. Now, we all know the cloud is here to stay. Now let's talk about why the cloud is so impactful on IT strategies. Each time I look at a cloud deployment, I find it easier and easier to stand up and configure a system. And because everything is service-based, it becomes easy to integrate to as well. The cost model for cloud deployments is always an interesting discussion. The cloud offers a great deal of flexibility in provisioning of resources. But if you're careful in your configuration and settings, you actually can have a very significant impact on reducing CapEx and OpEx costs over an on-prem system. However, if you're not, the costs can run up very, very quickly. Not having to be concerned about keeping systems up and running in your data center brings the availability of cloud systems close to that of the mainframe. The redundancy ensures that the systems will be there when you need them. But in my opinion, one of the greatest advantages of the cloud is scalability. I have several mainframe customers whose business is cyclical and requires them to provision resources to handle the worst case maximum load scenario. In down cycles, a lot of very expensive resources on a very expensive mainframe may actually just be sitting there idle. Now, for all the positive aspects of the cloud, like anything, there's going to be a speed bumps along the way. As we said on the last slide, costs for cloud deployments can be tough to nail down. Unless you have a lot of historical data, overall demand for resources is hard to determine. The first cost is that of getting out of your existing system and migrating to the cloud. It can be very difficult to estimate the cost to rehost or rewrite an application to make it cloud ready. The mainframe applications that I've been involved with have massive amounts of data associated with them. Disk space is not cheap, and to house that amount of data in the cloud may just not be practical or reasonable. CPU size and RAM are probably the easiest to calculate. The final hurdle is, what cloud provider are you going to deploy to? All the variables we've talked about already need to be factored into that calculation. An application that's CPU heavy may be a good choice for one cloud provider, but another application that's memory heavy may work better in a different cloud. So do you standardize on one provider, or do you chase the best price? Just something to think about. So let's begin our discussion now about hybrid IT. So we know what we have with our legacy systems, including their pros and cons, and we also know that the cloud, be it public or private, has its pros and cons as well. The first thing we need to consider is, do we redeploy the legacy system to the cloud, or do we create an integration strategy to that legacy system? The question is, how do my legacy applications fit into the hybrid IT strategy when it seems like everything is moving to the cloud? Is it really just a simple choice of, do I modify, rewrite, or replace my legacy application and deploy it to the cloud, which may provide me an easier path to integration, or do I leave it in place and find a way to integrate to it? With all the unknowns related to cost, subject matter expertise, and the rich history of these legacy systems, my tendencies are leaning toward integration in place. Let's dive a little deeper and see if I can convince you why I feel the way I do. Again, we're going to come back to that significant consideration, and that's data. As I said earlier, most legacy applications have a massive amount of data associated with them. Additional costs result from the specialized labor for DBAs and other support folks due to the non-relational nature of these mainframe systems. There's also added licensing costs for many of the database files like IDMS, ADABase, etc. Now, granted, those would translate to cost savings if we migrated some of the data to the cloud, but I'd submit for your consideration that these costs could and probably would be offset by the cost of hosting this amount of data. And what happens if you don't rehost all the data? Does that impact the effectiveness and usability of your new application for your customers? I think I can say with certainty that you're not going to drop your vSAM generation data sets up into the cloud. And this is an issue that has some far-reaching implications. because a good bit of the mainframe data is not relational. So the data is going to need to be converted to a format that's available in the cloud. Not only that, but all the programs to call that data will need to be converted. And this effort could be huge. You also have integrated file system like on the AS400, which may have its own set of challenges to migrate. So you say, maybe somehow I'll just leave some of the data behind and just do the transitional work on the cloud-based system. And that might work as long as you can keep the two systems synchronized. Not impossible, but will require a lot of thought and design. This may also be expensive from a time and resource perspective. And the final consideration on this slide is, how do you engage with these systems? Now, most likely it's through a 3270 green screen today. So you're going to need to build a new interface to that system. But if you're going to integrate, you may want to do that anyway. But you may not need to expose the entire system for integration. I think we can probably all agree that no other platform has been and still is more secure than the mainframe. And that's something to strongly consider. Security has been the mainstay of mainframe legacy applications forever. It can be debated that the mainframe is impossible to hack. Impossible is a strong word, but if the proper procedures are put in place, it should be almost completely impervious to illegitimate activity. So how do we translate these very sophisticated rules to the cloud platform? How do we determine what to expose and how to do it? In the real examples I've seen in my career, consider the question of how do you replicate the sophistication of RACF security in the cloud with field level, file level, program level, and all the other levels of security that are available. The applications themselves present their own challenges. How do you communicate to the COM area? Can you access the screen maps, or do you screen scrape? If you want to service enable, do you choose SOAP or REST? And finally, you have language issues. Now, we can easily provide you COBOL off the mainframe, but what about PL1 and RPG and assembler? Those will need to be converted, and that can be expensive. So if we conclude that we can't move the application to the cloud, then we're going to have to put together an integration strategy that leads us closer to hybrid IT. As I said before, I've been involved in many mainframe integration projects over the last 14 years, and each one is unique and presents its own challenges. But with the right strategy and tools, with the proper planning and attention to who's responsible for functions like data validation and security, these projects become very, very successful. The choice of how to integrate to the mainframe will have a profound impact on your organization, and making the right choice is the way to start. It's been my experience that there's a few options for mainframe integration. So let's talk about a few of them. The first is custom development. Just simply go out and roll your own integration solution. There's screen scrapers, a valid way to integrate, but limited functionality and can be very, very fragile. ESBs, another very good way to build an integration. However, depending on what you need to do, could be way too general. And then API enablement, probably the best solution, very functional if it's done properly. So let's take a look at these four options in more detail and see which one is the best fit for a practical integration solution. We'll start with custom development. Custom developed solutions are tried and true. Any good programmer can build a point-to-point integration solution. Now, I'm not saying that this is bad. What I'm saying is it's certainly limiting. These rigid solutions are dependent upon those who built them and may not scale or be flexible for future needs. These solutions typically have a much longer ROI due to the resources and time required to build them and to maintain them down the road. And time is a huge factor today, as all parts of the organization must react at the speed of business. And finally, because they are point-to-point solutions. If you introduce a new consumer, the work may not be reusable, which bumps up the cost even more. Buckle up, folks. We're about to jump into the Wayback Machine. Let's talk about the good old green screens. Well, here we are. Anybody feeling a bit nostalgic? Screen scraping conjures up some very, very polarizing reactions, and that's me being generous. Relying on the row column positions on a screen creates a great deal of anxiety for the developer. If anything on the screen changes, the whole process comes crashing down. It actually may be one of the most fragile ways of providing an entry point into the mainframe applications. Unfortunately, and I've seen this in several of my customers, it may be the only way. Creating one-to-one translations of screens is very cumbersome at best. One of the biggest complaints I hear from mainframe applications is the user experience. It sometimes takes months to master the navigation of a green screen mainframe application. And then try translating that to programming that navigation for a new UX for the purpose of integration. That solution becomes almost unworkable. Now, I know we've already talked about custom interfaces, but there's a variation of custom interfaces that do provide a plausible integration option. Two methods that come to mind when we consider an extension of custom interfaces is CTG and MQ. CTG is the CICS Transaction Gateway, a product that provides an API into CICS. Many applications have been built with CTG, but like most point-to-point solutions, it requires an extensive amount of programming. The same challenges we talk about in the earlier slide appear here. Resource intensive to build, lack of flexibility, relies on personnel that may not be around anymore, and finally, not every site has CTG because there's an additional cost for the software. MQ series is a message-oriented middleware. Probably its biggest intrinsic value is guaranteed delivery of the messages. But with that reliability comes a great deal of complexity. And with that reliability also comes a great deal of complex programming, configuration, and a lot of moving parts. In fact, I've had many of my customers moving away from MQ because it's just too onerous to maintain. In both cases, because it is program heavy, the learning curve can be very steep. Now, much has been said about ESBs, and I think we need to spend a few minutes on them next. The ESB, or Enterprise Service Bus, has had a profound impact on new development initiatives. The concept of the citizen developer now creating applications that were formerly done by highly skilled developers has become a game changer. If you look at the industry-leading ESB, they provide over 225 connectors to almost every application you can imagine, and if you can't find the one you need, you just create your own. And this makes it a great option for modern architectures and modern deployments. However, the story changes if the outreach needs to be to a legacy mainframe application. A few of the ESB vendors do provide a legacy adapter, and just to highlight that, I did the air quotes around it. The challenge is that support is limited and may require a level of development expertise that the ESB developer probably won't have. The ESB vendor will also not have on-platform support, meaning they have a server or agent that runs on the mainframe. Now, this may not be important for every site, but many of my customers prefer, even require, that processes that access and integrate to the mainframe run on the mainframe. So depending on what your end goal is, you may be able to get by with one of these options that we've talked about. But why would we want to compromise? Why would you want to compromise or program yourself into a corner only to have to go through the same exercise again by ripping out one custom solution and replacing it with another custom solution. The impact on your organizations and your customers would be extensive. GT Software believes that the best of breed strategy for mainframe integration solution is the best approach. So, to wrap up our time together today, I'd like to take one slide to introduce you to Ivory Service Architect. Ivory Service Architect provides an API integration platform for legacy ZOS-based applications. Ivory includes support for CICS COM area and channel and container applications, IMS transactions including IMS conversational, BMS and MFS transactions, TN3270, and external services. Ivory also provides outbound support, which allows the mainframe to consume SOAP and RESTful APIs. With Ivory, we provide a function-rich graphical environment for quickly building atomic or multifunction orchestrations, which combine multiple APIs into a single API. At development time, all the work is done with a point-and-click, drag-and-drop user interface, so absolutely no coding is ever done and no coding is created. Once the API is created, you simply deploy the SOAP or RESTful service, which is 2 mouse clicks, to the server and you're ready to go. For the runtime, Ivory gives you the choice of running the server on the mainframe, either under CICS or as a started task, on Linux for Z, under Java as a Windows or Linux application, or as an OpenShift container. And finally, all of this is done securely with access to mainframe authentication. If you'd like any additional information regarding mainframe integration with Ivory Service Architect, please visit www.gtsoftware.com. I'd like to thank you very much for your time today, and I'll be happy to take any questions that you might have. If you do have any questions, please enter them into the question panel on the GoToWebinar dialog. Okay, well, it looks like our first question has come in. The question is, are you making the case or are you saying that there's no use case for mainframe migration? I'm not saying that at all. I've got many of my customers that have done very successful mainframe migrations. Some of them are full migrations, which allows them to turn off their mainframe altogether. And some of them are targeted migrations, which allow them to migrate only a certain application. There's a lot of considerations that you have to make when you do that about language, about interface, about programs, about data, all the things that we've talked about before. And I'm certainly not saying at all that mainframe migration is not a valid consideration. All right. Okay, you mentioned the negatives of screen scraping, but you offer TN32 support. Why is your solution not bad? Well, what Ivory offers is a choice depending on what your situation is. If the opportunity is there to use the BMS maps for CICS or the MFS maps for IMS, we would certainly prefer that vehicle because that allows you to take advantage of all of the system functions for processing those screens. However, there's certain applications and there's certain scenarios where maps are not available. It could be that you've purchased a mainframe application from a third-party vendor and they haven't given you access to the maps. It could be a scenario like a natural database application where they don't use a mapping structure. And in those cases, if you have to get to those underlying systems, and the TN3270 is the only way to go, then we do give you that that capability. Okay. There's a question on how can we move data residing in the mainframe to Kafka utilizing Ivory. That's a two-part question. Ivory is not a data movement technology, and I apologize if I might have blurred the line there. Ivory is an integration technology, and the point I was trying to make throughout the presentation is that there's a choice that you can make between moving and migrating your application and the challenges associated with that, or leaving the application in place and building a direct integration to it, which would allow your mainframe to participate in the hybrid IT world where some things go to the cloud, where they execute very, very well and very properly, and some things stay behind and execute on the mainframe where they execute and behave properly there. How long does it take for a typical integration project? Well, that's a very good question. It's one of those, it depends. We have had some situations where people have built an Ivory API in 2 hours, right? Or even less, sometimes 5 minutes. It gets you the first pass through the application. However, one of the very nice capabilities of Ivory is that it gives you the ability to add decision logic, error checking, and other things into your API. So to move it from the happy path to a very sophisticated execution, that could take a little bit more time. But as you iterate through the process and you become more and more familiar, each one of those iterations may just take you a matter of minutes. Can you talk about moving banks systems from the mainframe to the cloud? I'm not familiar with banks systems. I'm not sure if that was a typo, meaning bank systems. A lot of it, and again, this is one of those, it depends. GT Software sells a product that allows you to migrate CICS applications off of the mainframe, and we will handle things like the application programs, the screens. We'll do the data conversion. We'll modify the programs and such on the fly. Other scenarios require a little bit more sophistication and specialization. So, for example, let's say it's an RPG application, or let's say a lot of the underlying stuff is assembler. There may be some more additional work that needs to happen there. What is the biggest challenge using your tool to integrate to the mainframe? Believe it or not, the biggest challenge, I would say, is not with the technology at all, because once all the pieces parts are configured, i.e. you have a connection to the mainframe, most of it is the negotiation and coordination between the subject matter experts for an application and the API developer. Now, the tool is designed in such a way that sometimes that's the same person. I've got many of my customers who will take their existing, mainframe developers who are also the subject matter experts, and they quickly become API developers because of the ease of use of the tool. But in other cases, it may just be the reliance from the API developer on the SME. There's also other negotiations that need to happen, like if we're talking about building a mobile or a web application, where is data validation going to take place? Where is authorization and authentication going to take place? So Once you get all those rules of engagement all defined, then you can move through the process relatively quickly. Is Ivory able to automate complex dialogues against legacy mainframe systems? I assume by that question that you may be talking about a little bit more of a sophisticated screen navigation. And if I assume correctly, that that's something that we can certainly accomplish. Obviously every screen interaction allows you to perhaps take different pathways through an application. So if you get to a particular screen and you choose option 1, it does one thing. If you do choose option 2, it does another thing. Or if you put a particular data value into a field, if let's say it's an hourly versus salaried employee, it may take you to one of 2 different screens for payroll information. All of those can be very easily simulated in one of our Ivory services and can accommodate, anything that you might need. What kind of ROI is realized using Ivory server technology? Again, it's one of those, your mileage may vary, but one of the things that we have found is that the API development is many times, could be 5 times, it could be even more times faster than a traditional API, development infrastructure. And you just, work the calculation backwards and, figure out how many APIs are you going to build, what's your hard and soft dollars, and work it back. We've seen ROIs of less than a year in some of our larger customers. I think that wraps it up for the Q&A. Unless anybody has any other questions, again, I'd like to thank you very much for spending the hour with me today. I've certainly enjoyed it. I hope you found at least a little nugget of the information to be useful. And as I said, if there's any additional things you need or questions you might have, please visit us at www.gtsoftware. Thank you. Have nice holidays and have a nice day.